All right, we're going to talk about factoring quadratic expressions. So factoring is rewriting the expression into the product of its factors. It's kind of super important to understand how to factor. We use factoring throughout all your other math classes, so it's really important to get this really solidified in your head. So what we're going to do is we're going to look at A and C first of all. So if those terms have the same sign, so if they're both positive or they're both negative, what's going to happen is we're going to find the factors of A and C, or ax squared and C, and add them to find the middle, okay? If they're different, we're going to subtract to find the middle. So we're going to find the factors, multiply them together, add to find 9, okay? So a lot of times, students, once it kind of clicks, they'll start looking at these and seeing the factors already in their head and finding out which ones add to give them these pieces here, okay? I'm going to show you a method that will kind of help you if you're struggling seeing the factors and writing them down. So what I'm going to do is I'm going to take and factor the first term and the last term. So the factors of x squared are x and x, and the factors of 20 are 1 and 20, 2 and 10, and then 4 and 5. Well, it says, oh, look, positive, positive, positive. Okay, so the sign in the first and the last are the same. So my factors are going to add to give me the middle. Well, the 9 is positive, so all the factors have to be positive. So I look over here at the factors of 20, because I have the factors of x squared, it's x and x. I know it's going to be positive, positive. Which one of these factors, sets of factors, add to give me 9? And I have to add them in such a way that they stay together. So 1 and 20 has to be together, 2 and 10, 4 and 5. Well, 4 and 5 add to give me 9. So now I would have like this, okay? So I would have these factors, and this doesn't make a whole lot of sense yet until we kind of look here and say, okay, this is 4x, this is 5x, so now we got to keep this up. When A changes, we're going to need to make sure we really isolate which piece goes into which parenthesis, okay? So here, I have a positive x squared, I have a negative 72. That tells me that I am subtracting to find 14. And I need to find the factors of 72 that their difference is 14. So I know the factors of x squared are x and x. The factors of 72 are 1 and 72, 2 and 36, 4, and let's see, 18, 6 and 12. And I'm running out of room because I also have 8 and 9. Okay, so I have 1, 2, 3, 4, 5 different factor pairs that are 72. Now, I want to look at this and I want to find which one of these factor pairs has a difference of 14. Well, that's 4 and 18. So notice it's a positive 14, so that forces my larger factor product to be positive. So x times 18, the coefficient has to be larger, x times 4, so this one's going to be negative. So now I know my factor here. X plus 18, x minus 4. Now, we were a little bit unique in that we didn't really care which x went in which parentheses, but we're going to start looking at what happens if I have an a that's different. Well, what happens if I have an a that's negative? Okay? There's a couple of different approaches to doing this. In your book, they say, well, the first thing is let's actually take out a negative 1. Absolutely fine. So that's going to force this to be x squared minus 13x plus 12. So now I know I have a negative out front, and when I factor this, I just have a negative out front. That is perfectly fine. It's not going to change my answers. So now I have x and x. I have a positive x squared, a positive 12. So they're both positive, which tells me I'm going to add the factors of 12 and x or x squared. I'm going to multiply those and add those together and get negative 13. So they're the same, so my sign has to be the same as my middle. Okay? If they were alternating signs, I would have alternating signs in here, and then it depends. Okay, so now my factors are 1 and 12, 2 and 6, 3 and 4. Well, which one of these adds to give me 13? Well, it's 1 and 12. So this becomes x minus 1, x minus 12. Now I've factored it. Okay? We're going to talk about the greatest common factor. So the greatest common factor is just taking something out of every single term. Okay, so I want to take that piece out first. So it's being multiplied. So if I look here, what does 6n squared and 9n have in common? Well, is there something in common between 6 and 9? Well, that's 3. What's in common between n squared and n? Well, they both have n. So now I'm going to reduce this by 3n. So 6 divided by 3 is 2. N squared divided by n is n. Plus, now I'm going to do the same thing with 9n. 9 divided by 3 is 3. N divided by n is 1. So there's my factored expression. 3n times the quantity 2n plus 3. Okay, so now I factored this. Now, sometimes I will pull something out. So notice here I have 4x squared plus 20 minus 56. Well, I notice that 4 goes into every single one of these numbers. So I'm going to go ahead and pull that out. Okay, so just to simplify my expression. Minus, let's see, 14. Okay, so now I've simplified it down. Now I look inside this parenthesis again. Well, does this factor? Well, I don't know. Let's see. So I have x and x. I see that I have a positive x squared, a negative 14, which tells me I have to find the difference to be 5. So do either of these have a difference of 5? Well, yes, this one does here. 7 and 2, it's a positive 5, so I'm going to make that a positive 7, that a negative 2. So now I'm going to rewrite this. I'm going to write my 4 here. Parentheses x plus 7 times x minus 2. So the greatest common factor, if there's something that you can pull out of every single term, do that first. So up here, my greatest common factor was actually negative 1. So I pulled out my negative 1 first and then factored my resultant piece. Now, what happens if A is no longer 1, okay? So let's say A is not 1. So I have 2x squared plus 11x plus 12. Now I have to factor the 2, and I have to factor the 12. So I'm going to use different colors so that way you can kind of see how those different colors and where those variables go into my parentheses. So I'm going to factor 2x squared. That becomes x and 2x. And then I'm going to factor 12. I'm going to factor it into 1 and 12, 2 and 6, 3 and 4. And hopefully you've noticed that the first term and my last term are both positive. It tells me I have to add to get my middle term. And the sign of my middle term is positive, so all these terms have to be positive. If the middle term was negative, the factored term of 12 would be negative, okay? So now I'm going to look to see how this works. So this is kind of a process of elimination. I'm going to start here, and I'm going to go like this. Well, that gives me 1x and 24x. That gives me a grand total of 25x. That is way bigger, a lot bigger than 11x, okay? Well, comparatively, I'm talking about the coefficient. So 25 is bigger than 11, so it can't be that. So now I have to try this method here. So I have to try this. This gives me 2x. This gives me 12x. That's 14x. 14 is not 11. So now I know that 1 and 12 doesn't work. So now I'm going to go to my next one. I'm going to go like this. I'm going to go, okay, well, that gives me 2x and 12x. That gives me 14x. That is not 11. So now I'm going to go 2x and 6. So that gives me 4x. This gives me 6x. Grand total of 10x. It didn't work, so I know it can't be 2 and 6. Now I have to check 3 and 4. Okay? If 3 and 4 don't work, then it would be unfactorable or not factorable. So I'm going to try this one here. I'm going to go 1 times 3 is 3x. 2 times 8 is 8x. That gives me a grand total of 11x. That works. So now I'm going to come up. I'm going to put my 2 parentheses in. And I'm going to start by putting in x and 2x. So I'm going to go ahead and put x here. And I'm going to put 2x here. So notice that I put x's in black and 2x is in orange. So when we're looking at this, x is multiplying 3. So that means x and 3 cannot be in the same parentheses. Okay? They have to be in different parentheses. So if x is in this first parentheses, that forces 3 to be in the second parentheses. Okay? 2x is multiplying 4, so 2x and 4 cannot be in the same parentheses. So that forces this to be a 4. There's my factored expression of x plus 4 times 2x plus 3. Okay? Notice here that when I'm doing this, 2x and 4 cannot be in the same parenthesis. Okay? It's very important that you understand that these are not, because a lot of times students will go, oh, well, that's 2x plus 4 in a parenthesis. No, if they're multiplying, they have to be in different parentheses. All right? Now, let's look at our next one. So now I have multiple factors of x squared. So I have x and 4x, and then 2x and 2x. And here I have 1 and 3. And I am going to subtract the product of my factors to find -4. Okay? So, if I come here, and I'm just looking at the difference, I'll figure out which sign gets negative and which sign gets positive. So if I come here, and I go, okay, let's go straight across. Well, that gives me x, that gives me 12x. The difference here is 11x. Okay? That's not -4, so I know it's not that way. So now we're going to go the opposite direction. That gives me 4x. That gives me 3x. My larger product has to be negative, so that gives me -x. That doesn't work, so I know it's not x and 4x. So if it's going to work, it's got to be 2x and 2x. So now I'm going to test it. So 2x times 1 is 2x. 2x times 3 is 6x. I'm going to subtract those, which forces 3 to be negative, which gives me -4x. So now I know my pieces here. So I have a black 2x here, an orange 2x here. Some of you are like, well, they're going to be the same, so it doesn't really matter. That's true, but I want you to visually see where these go. So the black 2x is multiplying the black 1, so they can't be in the same factor. Remember, I had to make 3 negative, so that forces 1 to be positive, because I need a -3. So that is going to force this to be -3, so I have 2x minus 3 times the quantity 2x plus 1. Now, we have some special cases, okay? So we have this special case that's called perfect squares. So if I ever end up with a squared plus 2ab plus b squared, that's going to factor into quantity a plus b quantity squared. And if I have a minus 2ab plus b squared, that's going to factor into a minus b quantity squared. So some of you guys are like, well, that's kind of tough to see. It can be. But the first thing is when I look at these, the first thing I'm going to do is mentally, I'm going to look at, notice here that my first and last term are perfect squares. Okay? So that's the key to this setup right here, is they're perfect squares. In the middle, I have something in the middle. Okay? And both perfect squares are positive. So I'm going to test this. So I'm going to square root 4. It gives me 2. I square root 36. That gives me 6. So if I go 2 times, so I'm going to go the square root of this times the square root of this, and then I'm going to double it. So the square root of 4x squared is 2x. 2x times the square root of 36 is 6. So 2x times 6 is 12x. I double it, and that gives me 24. So now I know that what I can do is I can go 2x minus 6 quantity squared. Could I do the same approach I did up here? Absolutely. It's totally going to work. These are just special cases to get you to try and start memorizing these. The last special case is we have the difference of squares. So that's a squared minus b squared. I have this perfect square minus a perfect square. If I do that, that's going to factor into a plus b times a minus b. Okay? So here, 25x squared and 49 are perfect squares. So I know that this becomes 5x, right? The square root of 25x is 5x. The square root of 49 is 7. So I have plus 7 and 5x minus 7. Okay? Now, could I do this process with this one? Yes, I'm just trying to get to 0. These are just trying to get you shortcuts to see that if I have the difference of perfect squares, I can simplify that really quickly into the square root of the first plus or minus the square root of the second. So, and sometimes it may not look like it's a perfect square, but numbers are. So if I had something like this, let's say I had 16x squared minus 36y squared. This is the difference of perfect squares. So now when I factor it, what's the square root of 16? Well, that's 4x. So I know it's going to be 4x and 4x. Well, what's the square root of 36y? Well, y squared. So that's going to be plus 6y and minus 6y. So the difference of perfect squares and the product of perfect squares, or the perfect squares here, is just quick methods for factoring. So factoring is really, really important to understand. We use it in essentially every math course.